Imagine you are preparing for a massive storm.
Right.
You're boarding up the front windows, you're sandbagging the front door, your eyes are just locked on the horizon, waiting for the wind to hit.
Like everyone does.
Exactly. But the storm isn't coming from the ocean. It is quietly seeping up through the floorboards right beneath your feet.
Yeah, that's a great way to put it.
And that structural shift happening beneath us is physical AI. So welcome to today's deep dive.
Glad to be here.
We are exploring a super compelling new article by Johan Steyn. It's titled, "The Robot Has Left the Laboratory. It is Now on the Factory Floor."
Which is just a brilliant title.
It really is. And, if you are feeling that baseline fatigue about artificial intelligence taking over white-collar jobs.
Writing emails, doing data analysis, all that.
Right, all the digital stuff. If you're tired of hearing about that, you are basically looking at the horizon while the floorboards are giving way.
Yeah, because the global boardroom is just completely focused on the wrong disruption right now. I mean, the actual first and by far the largest wave of AI deployment isn't happening in office cubicles.
It's physical.
Exactly. It's happening in warehouses, distribution centers, and on factory floors.
Yeah.
We are seeing this massive transition from software and screens to steel and concrete.
Oh.
And the evidence of what is occurring in these physical work environments, I mean, it is no longer science fiction.
Auto China 2026 really proved that, didn't it?
Oh, absolutely. The Beijing exhibition this past April, it's the world's largest automotive exhibition. But the showcase, it wasn't really the cars themselves.
What was it?
It was a fundamental restructuring of how those cars are actually manufactured.
Okay, let's unpack this, because the Xiaomi AI factory in the Yizhuang suburb of Beijing it's just staggering to think about.
It really is.
We aren't talking about a few robotic arms assisting human workers on an assembly line here.
No, not at all.
This facility operates 700 interconnected robots, 700, alongside 180 autonomous mobile transport units.
And they've basically taken over the entire physical workload.
Right, with central computers and AI agents acting as the managers of the whole process. And get this, they are producing a brand new, highly complex electric vehicle every 76 seconds.
76 seconds.
I mean, that's faster than making a decent cup of pour-over coffee.
Yeah.
By the time your barista hands you a latte, this factory has birthed a fully functional car.
And we should note, this is a functioning, fully scaled production line. This isn't some tiny pilot program.
But wait, haven't we always had giant robotic arms in car factories? I mean, we've seen that footage of massive yellow machines welding chassis together since, like, the 1980s.
Sure, yeah.
So what makes this new setup so revolutionary?
Well, what's fascinating here is the leap from pre-programmed repetition to real-time adaptation.
Okay, explain that.
So those historical robots you mentioned, they were incredibly strong, but they were essentially blind.
Right, they just did the exact same motion.
Exactly. They operated on exact hard-coded coordinates.
Yeah.
If a piece of metal was, say, half an inch out of place,
It would just smash right into it?
yep, or it would meticulously weld empty air, they just couldn't handle unpredictability or any environmental variability.
Wow.
If you walked into their operational radius, they wouldn't stop. They would swing right through you.
That's terrifying.
Yeah.
But human workers handle that variability instinctively, right? Like, you see a part is slightly crooked, and you automatically reach over to adjust your grip.
You don't even think about the micro adjustments your hands are making.
Yeah.
But facilities like Xiaomi's, they've actually solved that problem by creating a cohesive AI ecosystem.
So the machines can finally see.
Yes, these new robots are interconnected agents powered by advanced artificial intelligence that can actually, literally, see their environment.
Wow.
So if a part comes down the line crooked, they recognize the anomaly, they understand it needs adjusting, and they correct the error on the fly.
Just like a human would.
Exactly. But they're doing this continuously, operating at a pace and precision that humans simply cannot match.
Here's where it gets really interesting. How did we cross that gap? From a blind, repetitive welding arm to a machine that adapts on the fly.
It's all about language models.
Right. The massive technological barrier that just collapsed is tied to large language models. And we usually think of those models as chatbots, right?
Yeah, ChatGPT, things like that.
You ask them a question, and they predict the next logical word in a sentence. But researchers realized they could use that same underlying logic for physical movement.
Exactly. They created vision language action models.
VLAs.
VLAs. This is the convergence making this reality possible. A VLA bridges the gap between digital reasoning and physical space.
Okay. So how does that work in practice?
Well, previously, programming a robot to pick up a tangled bundle of wires or a strangely shaped car component that took months of complex coding.
Right, you'd have to account for every angle.
Every possible angle, the weight distribution, everything.
Yeah.
But now you can just give the robot a verbal instruction.
You just talk to it.
Yeah. The VLA processes that audio. It looks at the object through its cameras, understands what that object is within a three-dimensional space, and then calculates the physical action required to manipulate it.
That is wild.
It is directly translating language and vision into mechanical movement.
And they're using something called imitation learning to train them, which just blew my mind.
Oh, it's incredible.
The robots are literally watching video demonstrations of humans performing tasks. And the models are translating that visual data into direct mechanical mimicry.
Yeah, so it compresses what used to be years of painstaking line-by-line programming
Into just days.
days of observation. It's like a person watching a 5-minute YouTube tutorial in advanced woodworking.
And instantly possessing the muscle memory of a master craftsman.
Exactly. You can deploy these machines incredibly fast now.
And that speed of deployment is driving a massive strategic pivot, isn't it? Like, among the major automotive players.
Oh, massive. At Auto China, companies like XPeng, Chery, and Geely, they weren't just exhibiting cars.
They were showcasing humanoid robots they developed internally. But wait, does it actually make sense for a car company whose entire business model relies on selling vehicles to suddenly pivot to building humanoid robots?
It seems weird at first.
Yeah, it feels completely disconnected from their core competency.
Well, if we connect this to the bigger picture, it is actually a direct extension of the technology they already own.
Oh, interesting. How so?
Consider what makes a modern autonomous vehicle function.
Mm-hmm.
It relies heavily on sensor fusion.
Right.
That's where the machine stitches together data from radar, LiDAR, and cameras to create a highly accurate, real-time 3D map of the world around it.
So it doesn't crash.
Exactly. The car has to see the road, understand obstacles, make instant decisions about braking or steering. That is the exact same core technology stack required for embodied AI. A self-driving car is basically just an autonomous robot on wheels.
So a humanoid robot is simply that same AI brain, just placed into a bipedal body with arms.
Bingo.
Wow. So the vehicle factory and the robot factory are merging into a single AI ecosystem.
Yes, and Geely's founder even publicly stated his intention to make his company the largest robotics manufacturer in the world.
Unbelievable.
They are taking the billions of dollars they invested in getting cars to drive themselves, and they're putting that software into machines that can walk around a factory floor.
And they are scaling this at a national level, creating a complete convergence of transportation engineering and industrial labor.
That's total shift.
So let's talk about the economics driving this mass adoption. Because, technology doesn't scale unless the bottom line makes sense.
Always comes down to the math.
Right. Between 2023 and 2025, $7 billion in venture capital flowed directly into humanoid robotics companies.
7 billion.
Yeah. And the industry is projecting between 50,000 to 100,000 humanoid robot shipments in 2026 alone.
And the unit costs are the true catalyst for this revolution.
How cheap are we talking?
As these companies ramp up manufacturing, the cost of a humanoid unit is rapidly dropping to the $15,000 to $20,000 range.
Wow. For the price of a used sedan, a facility manager gets a worker that doesn't sleep, doesn't take breaks.
Do they need health insurance?
Right. And never calls in sick. And modern humanoids are hitting 16 to 20-hour shifts before they even need a battery recharge.
That covers 2 full human shifts on a factory floor.
When you put that math in front of an operations executive, there isn't a debate to be had.
It's an immediate yes.
So what does this all mean for the actual human workforce currently standing in those buildings?
Well, the International Federation of Robotics confirms these machines are deploying fastest in 3 specific sectors: automotive manufacturing, warehousing, and logistics.
Okay.
And when you examine the global labor market, those sectors employ the highest concentrations of lower-skilled workers globally.
Oh, wow.
Yeah, this isn't a matter of automating a few niche, high-risk tasks. The core physical labor of the global supply chain is being automated out from under us.
And we actually have hard data on the employment shockwave this creates, right?
We do.
There was a peer-reviewed study published in March 2026 in the Journal of Open Innovation. They analyzed a decade of employment data.
A full 10 years.
Yeah, and they looked at unexpected drops in manufacturing jobs. They found that almost a third of those surprise job losses can be tied directly to factories integrating AI.
30%.
Yeah. When AI enters a physical production space, human employment contracts immediately.
And Johan Steyn highlights this to prove we are not dealing with a projection of what might happen in the 2030s.
It's already here.
This is a measured, statistical reality of what has been happening for the last 10 years as AI slowly integrated into manufacturing.
Right.
The arrival of fully capable humanoid robots at scale simply accelerates a displacement trend that was already highly disruptive.
It totally recontextualizes the estimates from the McKinsey Global Institute.
Oh, completely.
Because a few years ago, McKinsey projected that between 400 and 800 million individuals globally could be displaced by automation by 2030, with upwards of 375 million needing to completely switch occupations.
And people thought that was crazy.
Right. Those numbers were widely considered alarmist. But Steyn points out that because of this explosive leap in humanoid capabilities in 2026, a leap McKinsey's researchers couldn't fully model at the time.
Yeah.
That 800 million upper limit is no longer an extreme worst-case scenario. It is the plausible scenario.
Because the sectors McKinsey identified as facing the earliest disruption, manufacturing, warehousing, agriculture, those are the exact environments where humanoids are currently landing.
It's happening exactly where they said, just faster.
Right. This completely upends the narrative that white-collar knowledge workers would be the first to face mass structural unemployment from AI.
But, we always hear scary job loss predictions with new technology.
Sure, every time.
When the mechanized loom, the assembly line, or the personal computer were introduced, people panicked. But the economy adapted over time, and new categories of jobs were created. Isn't this just another gradual transition that the global workforce will adapt to over the next few decades?
Well, historical comparisons fail here because of the sheer velocity of the deployment.
Velocity, meaning speed.
Exactly. Francois Roudier, the Secretary General of the International Organization of Motor Vehicle Manufacturers, he frames this perfectly.
What did he say?
Speaking at the Beijing Auto Show, he stated unequivocally that what is unfolding in manufacturing is not a transition. It is a revolution.
Calling it a revolution implies a speed and a violence to the change that a transition doesn't capture.
Precisely. And China's overarching strategy illustrates this competitive reality vividly.
How so?
Their 2026 government work report prioritizes the creation of an intelligent economy. They're aggressively integrating physical AI into manufacturing to produce goods faster, cheaper, and at a higher quality standard.
Specifically to export those goods to global markets.
Right. Steyn points out that the AI factory advantage compounds annually through continuous machine learning.
So they just keep getting better.
The robots get marginally faster and more efficient every single day. So a manufacturer in Europe or North America relying on a human-intensive labor model is competing against a benchmark that physical AI is resetting constantly.
Wow.
You cannot adapt gradually over decades when your competitors' production costs are plummeting toward near zero today.
Which brings us to the boardroom blind spots. Because if this revolution is actively happening and the data on displacement and global competition is this severe...
Why is nobody preparing for it?
Exactly. Steyn argues that corporate AI strategies are fundamentally flawed right now. Executives are pouring their energy into figuring out how generative text and data analysis tools will impact their financial and professional services teams.
The desk jobs.
Yeah, they're completely ignoring the physical AI rewriting the rules of their own supply chains.
Well, boardrooms are populated by knowledge workers.
That's true.
Their daily interaction with artificial intelligence is entirely digital. Automating a report, generating code, summarizing a meeting. They aren't spending their days walking the floors of a logistics center or managing warehouse shifts. And because they don't see the physical disruption in their immediate peripheral vision, it just remains an abstraction.
It's like buying a state-of-the-art titanium vault door for your house to protect your jewelry while completely ignoring the termites eating your foundation.
Exactly that.
Because Human Sciences Research Council has actually issued stark warnings about the consequences of this disconnect.
What do they say?
They note that without deliberate policy intervention, the massive productivity gains generated by physical AI will severely widen existing economic inequalities, specifically for lower-wage workers.
Yeah, because you can't just lay off a warehouse forklift driver and expect them to seamlessly pivot into a role as an AI prompt engineer in a high-tech knowledge economy.
Exactly. So how big is this gap between policy and reality?
Well, this raises an important question. What happens when technological capability outpaces societal planning. The global policy gap currently is massive.
It's really that bad.
Yeah. China is executing an explicit, heavily funded national industrial policy that embraces this physical AI shift. Conversely, most other governments are just operating on vague AI principle documents.
Right, just general ethical guidelines that sound nice in a press release but have no actual funding, teeth, or structural transition plans behind them.
Exactly.
Hmm.
A principles document doesn't address the immediate disruption of physical work.
No.
It doesn't shield domestic industries from the fierce competitive pressure of foreign manufacturers using AI. And it certainly doesn't fund the massive workforce retraining required before 2030.
Right.
But this isn't solely a crisis for governments to solve either. Social stability is a fundamental requirement for long-term commercial viability.
Oh, that's a good point.
If an industry displaces a massive portion of the working-class consumer base without a viable transition plan, they eventually destroy the very market they are trying to sell their products to.
Right, who's going to buy the stuff?
Exactly. Managing this intelligently is a boardroom imperative.
And the executives who realize this, the ones who integrate physical AI into their competitive strategy while planning honestly for the workforce consequences, they are the ones who will survive.
Yes.
Because if an organization doesn't survive this first physical wave of disruption, they won't even be around to worry about the second wave of white-collar automation.
You must secure the foundation of the supply chain before you worry about optimizing the corporate roof.
Well said. So, the robot has officially clocked in.
Indeed.
The physical wave of AI disruption has arrived. Any organization with a supply chain, a warehouse, or a factory that hasn't deeply assessed how this timeline impacts their operations is already falling behind the most competitive facilities in the world.
The paradigm of physical labor, as we have understood it for over a century, has fundamentally shifted.
It really has. As we wrap up today's deep dive, I want to leave you with something to mull over.
Okay.
We've talked extensively about physical AI driving the cost of manufacturing and labor toward near zero.
Right.
As physical goods become incredibly cheap to produce flawlessly by intelligent machines, how will that change our relationship with the objects we buy?
That's fascinating.
Will we reach a point where a human-made label becomes the ultimate premium luxury status symbol?
Oh, wow.
Will people pay a massive premium just for the slight imperfections that prove a real breathing human hand cracked at the item?
Yeah.
Something to think about as a storm comes up through the floorboards. Thank you so much for joining us for this deep dive. We'll see you next time.